Thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at preparing your students to take the ACT exam. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, I'm really excited to be joined by our two panelists, Tom Reardon and Jeff McCullough. Tom taught at Fitch High School in Austintown, Ohio for 35 years and has served as an adjunct professor at Youngstown State University for the past 38 years. As a T-Cube national instructor, Tom's worked on the development of TI SmartView and also more recently the transformational geometry Lua activities. Tom currently works in product strategy and development for Texas Instruments and is currently working on ACT and SAT prep materials. Tom, so great to have you with us tonight.
Good to be here.
And Jeff co-founded the TI-Nspire super user group with Bryson Perry. He teaches Algebra 2 and AP Statistics at St. Mary's Episcopal School in Memphis, Tennessee. In 2009, Jeff received the Presidential Award for Excellence in Math and Science Teaching, and he has authored the second edition of TI-Nspire for Dummies and the second edition of the TI-84 for Dummies. Jeff, thanks so much for being with us tonight.
Okay, this is a great way to start the school year. Here, start it off.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions you have to Jeff or Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the top of the WebEx menu and choose Audio Broadcast. At this point, Jeff is going to discuss our agenda.
So tonight we're going to look at a sampling of a workshop that Tom Reardon and I helped create called Leveraging TI-84 for ACT Success and Leveraging TI-Nspire for ACT Success. It's specifically written for the new revised ACT exam. Maybe you weren't aware that the ACT has changed recently. And we have skill builders. We have calculator steps for both Nspire and 84. We're going to share some of those with you here tonight, as well as some activities that have been designed for the ACT. In other words, these activities are built for the ACT that you can use in your classroom, which are kind of neat. So Tom's going to highlight some of those activities a little later.
Thanks so much, Jeff. And Tom is going to discuss our expected outcomes.
So we're hoping that you get tips for integrating the 84 Plus or TI-Nspire technology throughout your lessons to help your students understand the math concepts assessed on the ACT exam. Learn about the key areas of focus on the revised exam and discover strategies and activities to help your students be more successful both on the ACT exam and in your math classroom. So this is not just a quick fix. This is hopefully an extended help for your students.
Tom, thanks so much. Jeff, it's all yours.
Okay. So again, this is comes from the workshop that school systems can get. This is the official name of our workshops. And it's geared towards ACT success. And I know in a lot of schools that's a big deal. How your students do in the ACT is kind of a marker for schools. So one of some of the things we want to learn in this workshop is we want to be able to leverage TI-Nspire or TI-84 to promote success. We help our participants get more familiar with the ACT. Just knowing more about the ACT test, we're going to talk about that in a minute, some of the changes that have happened there, just help a lot. I want to be able to discuss strategies. One of the things, being a good classroom math teacher doesn't necessarily make you good at test prep. So there's a slight difference between test prep and being a good math teacher. And so we talk about some test prep strategies in this webinar tonight. And also, we want to be able to incorporate activities into the math classroom. So this is a breakdown of the old test. If you're familiar with ACT at all, it was somewhat predictable. Trigonometry was always 4 questions, for example. I knew that, ironclad. There was a lot of geometry and a lot of algebra in there. And the test has changed. So in December of 2016 was the first administration of the revised ACT, and they break it down a little differently. So now they call preparing for higher math is the high school math that was on there. About 60% of the test is what we might call high school math, and about 40% of the test is what you might even call middle school math. And so just to tell you what the high school math is on there, they give you kind of a range of values, so it's not an exact number. A lot more statistics and probability that may stand out to you that was not on the last list. A little less geometry, and just kind of a little different variety. And that's for the high school portion. And then for the middle school portion, the topics are stuff you might expect, you know, percentages, area, volume, mean, median, but they're gonna layer skills together to make the questions harder and use more varied questions in that to make those questions as difficult as possible. So this is something that really stood out when we looked at the raw scores. So on the left here, if you take the ACT, you know there's 60 questions on the test, so in the math section. So if you got all of them right, it doesn't matter when you took it, everyone got a perfect score if you got those all right. Now, it depends on the year, but some of these other scores, so 30 is kind of a mythical score for students. They want to get a 30, oftentimes my students. And so you'll notice a big difference here. In December of 2015, if you missed 7 problems, you got a 30. But in December of 2016, if you missed 12 problems, you got a 30. That's a pretty big swing here. We think that the new exam started December 2016. We think this is Tom, don't you think this is the toughest exam we've seen of all the ones we looked at?
Yeah, the December 2016 for sure. For sure.
Yeah, and so if you look at the scale, it continues here, but the trend is it's graded more favorably, but you've got to get, so now if you get half of it right, you might get a 21 or 22 there, whereas before you had to get a little bit more than half right to get that same score. Although it is interesting, if you get 0 questions right, which would be really tough to do unless you left them all blank, you get a 1 no matter what. This is something that students, there's kind of an urban myth out there that now my students tell me, oh, well, eeny, meeny, miny, mo, I always just guess, and sometimes I just guess C because C is the most popular answer. If you look at the table here, you can see that in December 2015, A, B, C, and D, and E, they're all pretty equal. There's not a big trend towards one answer or another. I think they do that on purpose, and that was just interesting to look at. But we want to kind of sample you with a systems activity. So if you had a question like this, which is an ACT question, what is the value of y in the solution of the systems of equations? So basic systems problem. In the chat window, Tom, can you ask them how would they solve this problem? Can you ask that question in the chat window? And if you have a response, it'd be great if you could just type that in for me. So how would you all solve this? Solve that system. So matrix, can you be more specific? What type of matrix? What would you do with the matrix? I definitely see elimination there. Row reduced echelon matrices. Graphing with a calculator and finding intersections. I see that. Trial and error. So I kind of like that. Sometimes as math teachers, we don't validate the old guess and check methods, but that's approachable for all of our students. I've actually seen them solve system problems by trial and error. Substitution, and that might mean a substitution, or it might be to substitute the answer choices. I like that. Solve for y, solve for x, plug it in, so substitution method there. Any other methods you might think of? to solve a system. Okay. So one of the things we want to encourage tables, maybe, students to do in our classroom, especially with test prep, is to show work. Oftentimes, the mistakes I see with students when I tutor ACT is they skipped a step or two and they're not showing their work. So show your steps. Also, as teachers, it helps us see their thinking and catch their mistakes. But this is big, and this is something we want students to be able to be problem solvers, so be open to other ways of solving problems. So some of our strategies are based on other ways of solving problems rather than the traditional kind of mathematical approach to solving a problem every time. I always want them to be analytical thinkers, so which answers can I eliminate? That's always a great topic of discussion in my class when we're doing test prep. And just in general, when you're learning new calculator commands, don't let them touch each other's calculators because, and I don't know if you all do this, but they tend to just do it for the other person, and then you don't know how to actually type it in yourself. So I always have that as a rule. Tom, I think, are you in agreement, Tom? This is my favorite ACT question. Would you agree with that? Is that your favorite ACT question as well?
It's not my favorite one. It's not so much my favorite question, but I think the solution methods are my favorites.
Yeah. So what I'd like you to do right now is take a minute and solve this problem. So this is an ACT question from December 2016. I'm going to give you a minute to solve it. If you solve it one way, try to solve it another way. I've just asked a question in the chat window. How did you solve this? What method did you use to solve this? So set up a system and used elimination. And second line, third line, subtract the first. So the difference between B and C was 90. Interesting. Maybe all four of them add up to 360. So that's interesting. So A and B are cute, and so maybe figured out that C and D must be obtuse because of that. And if you know that, what's interesting is you can actually eliminate a lot of the rest of the answers just by knowing that C and D are obtuse. I had a student tell me that was how they did it. They didn't do any calculations. So just to show you one method that you could use here is you could set up a system of three equations. A and B is 90, A and C is 180, B and D is 180. You could add up these two, A plus B plus C plus D is 360. So those must add up to be 360. That's where some of you came up with that. And then you could substitute, well, A plus B is really 90, so you could substitute 90 in there for A plus B and then solve. But what's interesting about this question is we really don't know exactly what C and D are individually. And students, don't you think, Tom, in our classrooms, we don't ask questions like this very often. Usually we know what C is and we know what D is when we ask them a question. What do you think?
Yeah, I agree. And not only that, there'll be kids who will think they have to find both C and D and add them to get the answer.
Yeah,
and they can't.
So they're stymied, right? How do you do that? And I think some of you may have done this, but I thought it was interesting. Some of my students actually graphed this. So they drew a graph of A and B. They said, well, they add up to 90, so they drew it. Then A and C add up to 180, so they drew that. And B and D add up to 180, so they drew that. And they noticed that it actually formed those angles form a circle, or form a 360 degrees. And so C plus D must add up to 270, and 270 is the correct answer there. But this is a strategy. This next strategy I'm going to show you, drawing it's really neat, and we think that's a great idea of doing. But this is really one of the most efficient if you just choose a value for A and B. So you could have chosen 10 and 80 or 30 and 60. Choose any value you want for A and B as long as they add up to 90. If A is 20, then C would have to be 160. If B is 70, then D would have to be 110. And now you know what, I mean, isn't that interesting? So the question is C plus D. If you add those up, it's 270, and you've got it. And it's interesting because math teachers don't gravitate to this, but when you start talking strategies with students, they'll gravitate to substituting numbers in there instead of variables because it's easier to work with. And so that becomes a very quick way of solving this problem. And so just being open to different ways of solving a problem we think is really important with students. We want to build better problem solvers in our math classroom. And so sometimes there's not a prescripted way of solving a problem. This next thing is a strategy. So we go over a number of strategies in this workshop, and this is one of them. It's called Don't Fall for the Halfway Answer. So I've given this problem to students, and it looks like, Pythagorean theorem problem. It's a lot of my students know Pythagorean theorem, so they're very quick to start solving this. They do all the work off to the side, and they figure out that length is 40. By the way, Tom, is this a problem? I know you did an activity on Pythagorean triples. Is this a Pythagorean triples problem potentially?
Oh yeah, this is. It's 3 times 8, 4 times 8, 5 times 8. So yeah, this is good. And this leads into what I'm going to talk in about 20 minutes. Yep.
Oh, nice. So I mean, you could have even figured out it's 40 by just using Pythagorean theorem triples if you knew your 3, 4, 5 and figured out that was a version of that. However, what happens to a lot of students is they do all the right math, they get the answer of 40, and they circle it, and they think they've got it. And that's the tragedy, is they sometimes don't. They expected the question to ask how long is the hypotenuse, but actually 40 is not the right answer there. If you read the question, the midpoint of AB is how many inches from A. So the midpoint is somewhere around right there. Half of that distance of the hypotenuse is only 20, and so 20 would be the correct answer. So there's a fix for this strategy, and the fix is really this: always reread the question before you answer it. And I don't know why this helped, but this inverted pyramid really helped me understand it. I think it helps my students. So in English class, or when you're reading a book, the first sentence of every paragraph kind of summarizes the paragraph, and then you have a bunch of supporting sentences that support that. When you read a math question, it is the opposite of that. So a math question may start with, the length is 4, the width is 5 more than the length, the height is blah, blah, blah. And so they talk about all these little parts, and then finally the last sentence is the kicker, and you don't know if they're going to ask about the volume or the surface area or what they're going to ask. And so when I say reread the question, I don't mean reread the whole paragraph. I mean reread the very last sentence. Did you answer the question that was asked? This is something that even if you teach AP class or any class really, lots of times students don't answer the question that was actually asked. They ask what they think it was going to ask. So this is just a problem you can do here for a second. I'm going to give you a minute. See if you can find the halfway answer. See if you can apply this strategy. Find the halfway answer and then find the real answer for this problem. Because my students, a lot of them mess this problem up actually. Just try it for a second. See if you can identify the halfway answer. Tom, I don't know about you. I know you and I have taken a lot of these tests ourselves as students, and this is where I mess up the most. I will miss a question, not necessarily because I didn't know the math, but because I didn't read the question carefully. Do you ever struggle with this at all?
Oh yeah, because you start to, especially as a teacher, you anticipate, oh, this is the question I would ask, and it's not maybe the one they're asking.
Right.
And I think I remember this. I just forget. I think a good halfway answer, and it would be just. It's disturbing because the wrong answers are really good answers. They're not random. They know what students are going to do wrong. They're called distractors.
Yeah. Right, and so that's a good point. And so in my classroom, we talk about the wrong answers as much as we talk, and I think that's right. 129, Nicole just said is, and Jennifer said is the halfway answer. And if you do some of the math here, you do get, 129 shots were made. And so a lot of students see the 129 and think, oh, I've got it, 129. And so just pointing out to students that these wrong answers or distractors can be kind of an aha moment for them. Oh, they knew I was going to get that. That's not the right answer. And so the fix, again, is make sure you reread the question. If you read the question, it says how many points, not how many baskets. And so points, you've got to, these are 1 point, 2 point, and 3 points. So you've got to multiply these 54 times 2, 15 times 3, and then add them up to get 213. And so you can see how students could really fall for this. And if they're not aware that, hey, did I answer the question that was asked? I actually don't think it's worthwhile for most students to check their work on a test. We don't have time to check every problem like they do in a math class. But rereading the question, hey, that last line, did you answer the question that was asked? That is worth your time on these exams, because time is a real issue on these for sure. This is a TI-Nspire skill builder called substituting values. And in the workshop, we learned you can use your calculator about 5 or 6 different ways to substitute values into a problem. I know that you can solve this problem like this one, what value of x makes a proportion below true. You could solve this like an equation, cross multiply, or solve it different ways there. But a lot of my best students actually have got in the habit, they prefer, and they think it's faster, and sometimes they just prefer to substitute answer choices in, like someone was saying earlier in the chat window. And when you do that, we also talk about strategies. We often have them start on the middle answer. And the reason is these answers are written in order, like either smallest to biggest or biggest to smallest. So we recommend starting with 12 if you're going to substitute values in here. And so I've got the keystrokes over here on the left. So I want to enter 35 over 42 as a fraction. So I'm going to get out my TI-Nspire. So I'm going to enter a fraction. So control divide, and 35 divided by 42 is, I believe, 5/6. And I go back to this, so now I need to enter 10 over 10 plus x. So again, control divide, 10 over 10 plus x. So I'm going to enter the expression just like it is. And I really like this feature. It's called the constraint command, or the such that command, the constraint operator, I think. And so if you hit control equals, and actually I learned this in the workshop, if you click the left arrow, it goes down to that last choice just to save economy of strokes, and choose the vertical bar. That's the such that command. And then you can type in x equals 12. And what that does is it substitutes that value into the expression, and you get 5/11. Now, one thing I really like about doing this, if you want to substitute a lot of values in pretty quickly, you can copy and paste that. But first thing I want to ask is, if 12 doesn't work, we got an answer of, let's see, 5/11 instead of 5/6. So our answer was too small. We need a larger ratio. So we need that denominator to be smaller, actually. So I think we can probably eliminate 17 and 32, maybe try 7 and 2 there. So if you just copy and paste by mouse, just like on 84, if you mouse up and press enter, Now I can delete that answer and type in 7, and that's not the right answer. But if I copy and paste again and change it to 2, I believe that one does work. So 5, 6 is equal to the ratio 35/42. So I love being able to just change. I don't have to go back and edit the expression, just the value of x, and that is just really handy to me. Again, these steps have all the screenshots and steps to go along with them when we teach our students or teachers how to do that. So Tom, I'm going to go real quick on this one. I know I'm about to pass the ball, but I'm talking about one more strategy, which is graphing on a tough problem. And so this is kind of actually this is if you ever, like I'm the Mu Alpha Theta sponsor at my school, so I help some of the math contest folks. When you get to a tough problem, I always think it's a good idea to graph it. So if you read this problem, one solution of the equation, there it's got a cubic is x equals -1, which of the following describes the other 2 solutions? So they get to a problem like this. This is pretty tough. If you think about the actual math of this, you know, they'd have to do synthetic, maybe do synthetic division or long division there. They get a quadratic, and that doesn't factor, actually, so they'd have to do maybe quadratic formula, or at least the discriminant of the quadratic formula, and figure out that those are complex roots, and maybe choose choice K at that point. But I think it's actually easier for students if they just graphed it. So if you just graph this in your calculator, you see that it only crosses at 1 point there. And once you see that, you can eliminate 3 of the answers right away. And the only thing we have to be careful of is it's maybe not a triple root. Maybe it crosses there. And so it's not because there's a 4 in front. The root is not, x plus 1 to the 3rd power. So I would choose K at that point. But just seeing the other roots, you could easily just see, is there other positive roots, are there other negative roots? And it's a much quicker way of solving a problem like that. So Tom, I'd like to turn it over to you. So I'm going to give you control here. And Tom is going to talk a little bit more about, he's going to use the 84 and a little bit more about the activities as well, which I think you might be interested in hearing about. There you go, Tom.
Okay, so thanks, Jeff. Before we get started, I would like to point out a couple people that worked on this that aren't here tonight. Judy Hicks and Betty Gasquey helped quite a bit with this, and Patrick Flynn also helped a lot with this. So thank you, guys. All right, so I'm going to be focusing on the 84 CE ideas, and let me go ahead and get this going here. So I'm going to talk about the Pythagorean theorem and triples activity, similar to what Jeff said before, but a little bit of an extension. So these are 2 problems that were recently on the exam, and we're going to look at solve those in a minute, but I thought I'd like to at least have you see them. This one's right up there with me, was that last problem Jeff had with the A plus B plus C plus D. It's pretty up there, pretty high. So one of the things I would want to get across is the creators of the ACT test, the topics that we teach, but they ask their questions very differently from what we ask and how textbooks ask. And that's something, it took me a while to get over that, okay? So if your students know and can recognize Pythagorean triples, I guarantee they'll do better on the ACT and also in future math classes. So if you haven't been doing that, I strongly urge you to consider that. So what we're going to do is we're going to look at a program that was created for helping students recognize and know the Pythagorean triples, because if you do that, you're going to save time, and that's one of the big deals on this test. So let me go ahead and bring this up. The program's called PythTrip. Sorry, it sounds awful, but Pythagorean triples, PythTrip. We'll run that program. And the first thing is it a triple or not? Okay, so again, students can work at this at their own pace. So I'll press 1 or enter. And given 3 numbers, we need to decide if they form a Pythagorean triple or not. Press enter to continue. So 3, 4, 5 is a triple. It says if it is, enter the number 1. So I'll enter 1 and enter, and I'm correct, okay. Press enter. 4, 5, 6, we know that's not a triple, so I'm going to go 0, and it tells me you're correct, it is not. Now the next one I'm going to goof on, I'm going to mess up on this one. I know it's a triple, and I'm going to say it's not, and it tells you whether you're not. Okay, so it goes on with several of these, and I think you see the idea there. So I'm going to go back to 9 for the main menu, even though I'm not finished. I can do that. Now, once they know if they're triples or not, the other thing is, can they finish a triple? So this is number 2. And so 6, 8, what makes a triple? And hopefully they know that it's 10. And it says, yes, 6, 8, 10 is a triple. And you'll notice I had it put in there so that it doesn't just say, yes, it's a triple. I want them to actually say 6, 8, 10. I want that connection being made. 5, 12, I'm going to be wrong on this one and go with 14 and say, sorry, no, the answer is 13. Again, 5, 12, 13 is a triple with the emphasis on those 3 numbers being together. Okay, 8, 15, I think you get the idea here, so I'll just skip to the next part. The missing number in the triple, this is a little bit another level up, I think. 5, what, 13? And of course, if you put in 12, yes, you're correct. You get reinforced there. Something 15, 17, I'm going to go with 10 because I'm not really good at this. And so, no, sorry, it's 8, and so on. So I'm just going to go ahead and go to the last part. And the hardest part is number 4. That's the hardest part of this part. Quit. So notice that I'm still even advertising. Even at the end of the program, I'm saying, make sure you know these guys. These are the Pythagorean triples. So anyway, we're suggesting in the activities that students do this, so I'll go back to the slideshow so that you can see from here. So now I'm hoping they know the triples. So this is back to the ACT question. This is December 2017, number 32. And it says, which of the following values is closest to the distance in feet between A and B? So I'm just going to give you a few seconds to think about that. You may not have enough time, but just kind of get an idea. And so about 15 seconds. Yeah, Jeff, there is a halfway answer. Good point. So, so for this one here, if I were doing this, the first thing I would notice is 9, 12, 15 in thousands is a triple. Not that we needed that because it does say it's a right angle. So next I'm going to look at this one and I'm going to notice that something 12, 13, well 5, 12, 13 is a triple, so any multiple is that. So this is 5,000. And as Jeff said, 5,000 F, that's a really good halfway answer. As kids will say, oh, what are the chances of me getting 5,000 it being wrong? Well, unfortunately, really good here. So that is the partial answer, but the real answer, of course, is for 14,000. So this is done quickly if you know the Pythagorean triples. If you don't, you'd be saying x squared plus 12,000 squared equals 13,000 squared. And with a calculator, which you're allowed to use on every single question on the ACT, you'll get it probably, but as Jeff mentioned before, time's your biggest enemy. I mean, if you can pick up time, that's where you can really do much better on the test. So again, Pythagorean triples. This one here is right up there with my top favorite problems here from 2017. Here, a quadrilateral wants to know what's the tangent of angle A. So again, let me give you about 20 seconds to think about this one. Might not be enough, but give it a shot. So my claim on this one is that if you know the Pythagorean triples, this problem is done very easily and quickly. And if you don't, you may never get this problem, okay? So for this one, also one of the strategies that Jeff had was draw auxiliary lines, especially for geometry. So if you draw a segment BD and you see 3, 4, and hopefully 5 jumps out at you, but if not, if you use Pythagoras' theorem, you'll get the 5, just not as quickly. And so you got a triple there. And so here's where, if you don't recognize this as a triple, you could be here forever, okay? So here's another triple, which means there's going to be right angle right there. And now the tangent is opposite over adjacent 5/12. So again, if you know them, great. And if you don't, you may not ever get this problem, unfortunately, okay? And as I've been working with school districts around the country, and especially around this area, there are teachers who teach Pythagorean theorem, but not triples, which I would suggest you do that. And some of them don't teach multiples of triples, which I also highly recommend, especially if your kids are taking ACT or SAT. So, there.
Yeah, it was surprising how often we saw triples on this test when we looked at triangles. It is surprising, I think.
Yeah, I agree. I agree. So here's an example of the activities. There's 15 on the 84 and 14 on the Nspire. And so I thought I would just show them real quickly. So this is the one that goes with Pythagorean theorem and triples. They're pretty much the same. They start off by reviewing what kids should know, and then kind of build up to more and more difficult things. So here's just finding missing sides, not a really big deal here, but it also says, while you did that, did you notice any whole numbers that were working, which were called Pythagorean triples? And then decide if it's a triple or not here, you know, and then in problem 3, it says, how about multiples of triples? And again, this is a place where some kids didn't hear that before. And then families of triples, so they could generate a family. And then this one was one that Jeff kind of liked, was how about if we construct a 3, 4, 5 on here, the 3, the 4, and then use a compass to show that that length is actually exactly 5 units, or a 6, 8, 10, or 5, 12, 13. It kind of reinforces that this thing kind of does work. Here also show them that distance formula is really based on Pythagorean theorem, and then some applications.
Really, they forget that distance formula all the time. You know,
so
I mean, just for them to see that they could actually use the Pythagorean theorem on the graph.
Yeah, I agree. And then here we have this man walking problem, person walking problem usually in there. So after all these are there, then we have sample ACT questions, and this one looks really familiar, and this one was the one Jeff did before, and the one I just did there as well. So one of the things that I would like to point out is when I did this with students, and I did this with 4 different classes of students, I worked with 25 students all day in different high schools. And as they were doing some of these problems that we created, you could see them going, this isn't how we learned it in our class. Our teacher never made us do this. But as soon as they got to these problems, the actual problems, you could see the light bulb going off going, oh, that's why he made us do it that way. And I'm telling you, this is a way of getting them to latch on to what you're doing. You give tests all the time, but this is a big test here. So they want to know how to do better on this test, the ACT, that is. So. All right, so let me go back.
Like in the activities, many times we're looking at it from many different angles, kind of doing it forwards and backwards, and more open problems, not necessarily one way to solve the problem. And by doing that, they really get that concept in there, don't you think, Tom? And then do better on those test questions.
Yeah, I'm glad you brought the backwards and forwards. I sometimes call them Jeopardy problems, where you go backwards. Like, here's the answer. How could we get there, and so on. So yes, exactly. And I'm glad you also stopped me. I forgot. This is the teacher notes and solutions that goes with each of the activities. Starts off with a lesson plan. And you don't have to use this lesson plan, but when we made them, we thought this is the best way. Really big into think, pair, share strategy, where kids think about it on their own, no collaboration. Let them think their own thoughts, then pair, then maybe share with the group or the class. So, and then this is exactly the same as what the kids have, except solutions are pointed out, how to get answers are pointed out, some strategies are pointed out. So there. And that's with all of the activities. All right, so back to the slideshow. All right, so skill builders, substituting values. Jeff showed you a little bit on Nspire, and I love the such that key. I mean, that is like one of my favorite keys on Nspire ever. So this one's substituting values using the 84 CE. So I just created this one here. What if I had this rational function? I had to evaluate it at 3. What are all the different ways you could do this? So let me go ahead and pull up a calculator for this one. And so what I'm going to do is I'm going to go into y equals, and I'm going to type in that expression into y equals. And actually, I already have. Okay, if you see that there, I already have. So let me go ahead and make that bigger so maybe you guys can see that. In case you didn't know how to get that there, with the new color, you can, and the more recent grayscale, alpha y equals has the nice fraction template, which I love, okay? But if you have the new color and the latest operating system, you can also get that fraction template by pressing alpha and the xt theta n key, okay? That sometimes gets wows. I think I heard a few wows from across the country right now on that.
That was great.
So x plus 1, and then over x squared minus 2. And so that's how you can go ahead and get the function in there, okay? So I already had it in one. I'll just clear it. I just want to show you I could get it there. And then I'll go off to the home screen, and some of you, to get the y1, you'd go and just do alpha trace. That's where all the y guys live. And so we want y1, and we want to evaluate that at 3. Okay, so let me go ahead and pull that back up here. So y1 at 3 is 4/7. I'll pull that off so that we can see that better. Put that in there. So that's one way to do that, using y equals or function evaluation. A second way would be graph and trace. So if I go back to the calculator and make it big here, under y equals, let me turn that on so that it graphs. And I'm going to go ahead and
you just click on the equal sign and that turns it back on?
Yep.
Get it turned off. Yeah.
Yep. Thank you. Yep. And I have most of them turned off, right? So I'm thinking I have a zoom memory here that's a nice square window, more of my favorite ones. So let me zoom recall that. Yes, there it is. I like that window. So here I graph this function, and when I go to trace, I want to find out what it is when x is 3. Well, I could be clicking for a long time. And as most of you know, if you want to trace your particular number, you just type the number. It says, oh, that's what you want x to be equal to, and so x is equal, or y is equal to 4/7. So I'm going to go ahead and just pull that off so you can see that as well and make it big so you can see it. So graph and trace would be a good way. And the reason I'm showing these is that there'll be some ways are really good for your kids and some maybe not working so well for your kids. A table is another way we have. So here I'll pull up calculator, and we still have that function there. I'm going to check the table set. Starts at 0, changes every 1. I'll keep these at automatic. And table's blue above graph. So second graph is table. And I want to know when x is 3, what's y, and it's clearly 4/7. So again, I can pull that off so you can kind of see that as well. Now, there's 2 table ways to do this, and Jeff reminded me of this when we were talking about it, what I call the alternate way. And that is, if I go back to the table set, second window, if you go down to independent and go to ask, in case you've forgotten what that does, if I go to table now, it's waiting for me to ask for the value of x. Like, I want to know what it is when x is 3, I type it in. If I wanted to know what it was for x equals -2, I type it in. So you don't have to flip through the whole table. You can just get the ones you want. And so that's what I call an alternative way of doing that one.
That is pretty neat. I mean,
yeah, it is, especially when you do like 4 or 5 values real quickly. There you've got them.
Yeah. You can actually take the answer choices and do them, I mean, in there if you wanted to.
Perfect. Oh, I like that idea. Yeah, I like that idea. So you get a Pez. That's a good one. I like that. Okay. Okay. Where are we? So I also want to show graph and table simultaneously because this is like one of my favorite things, and it's been around since the 81, old blue, but a lot of people forgot about it. So for this one here, I'm going to go to mode, and normally you're in full screen, but I'm going to turn right and go over to graph table. Now on the grayscale calculators, it will just say GT, just because there's not enough resolution, but it's there. And I'm going to go ahead and press second graph, because really I'm in the, oh, I forgot to change my table. Sorry, let me go back and change my table so that I'm not in that ask mode. Sorry about that. I feel awful now. Feel awful. So there we go. Right now I'm at 0, and here's the part I really like. Watch what happens when I press the down arrow. Look at the table and look at the graph. And you are able to see both at the same time. And to me, to make this connection with kids, especially younger ones or students that have a difficult time, this is just amazing. And if you really want to get into it, you could actually show what I call the big three, and that is the equation, the graph, and the table all simultaneously. And to me, that is, you know, a big deal. So anyway, that's, now I like it, but when I'm not using it, I don't want to use it. So I'm going to go down to full and go back to full mode there. And there. All right. So going back here, let me just recap this real quickly. So this was the using y equals, alpha trace gets you the y guys, y1 at 3, and there it is. Graph and trace, just go there, trace to x equals 3, and it gives you the value. The table, again, you can start anywhere and then just kind of go down to the value you want. The alternative way is to use the ask mode and put in the number that you want, and then, of course, graph and table simultaneously. You do have to change it to graph table, and there you go. All right,
yeah,
so
don't use table enough. You know, just with students, it's just such a good. Don't you feel like it's a great way to represent and see all those values?
Absolutely. In fact, what's our main thing when we want the kids to think algebraically, but we also want them to think what? Graphically and by table. Yeah, we want them to see that.
Right.
That's think that way.
Yeah, when you think about calculus, you think about all the full representations there. That's true.
Yeah. So why would they need to do this? Well, in April 2017, problem number 4 was evaluate this function at 3, okay? So I'm going to go ahead and just go right directly to the calculator here and type that in. I'm not going to do this one live. I was just going to kind of show it. But type it in here, okay? And then I'm going to go ahead and go to Y1 and ask for Y1 at 3. Just like I would say F at 3, and it's telling me it's negative 60, and fortunately that's there. So now, I should point out, in my classroom, this would not be a graphing calculator problem. This should be a by hand problem. But on the ACT test, this is a high stakes test, and number 1, they are allowing a calculator, so if they're allowing it, it's fair game. And number 2, think about the high stakes it is. One question could be the difference between getting into the college you want or not, or getting thousands of dollars of scholarship money or not. So if they're allowing it, I'm suggesting it. But I would like them to be able to do this by hand. I just want to go on the record there on that one. Also,
yeah, Jeffrey was saying that it protects from errors, you know, from distribution errors, or like when there's a negative. So often those kids will get it wrong when you're plugging in, you're substituting some negative value in there. They just, you know, don't type it in their calculator correctly.
Right. You have a negative number, you got to square it or something. Yeah, just who knows what's going to happen. And so it may take a little longer, but at least I know I'm right unless I type wrong. Composition of functions also could be done this way. I could type in f of x into y1, g of x into y2, and then again, use alpha trace, get the y variables from there, and take y1 of y2 of 4, just like f of g of 4, and when you press enter, 31. So this is, to me, a very big help. But some teachers have asked me, will it do f of g of x? I would love it, but that would be a CAS calculator, and CAS calculators are not allowed on the ACT. They are allowed on the SAT, but not the ACT. So the 89 and the Inspire CAS would be fine on the SAT. This next one's a little bit different. It says evaluate this function at a function of 3 variables. Now, Jeff could have done this with Inspire. You can define a function in 3 variables and type it just the way you see it, and it would evaluate it. Yeah. Not so with the 84. So for this one, how I would do this, in fact, let me just do this one with you. How I would do this one is...
this is interesting.
What's that?
This is an interesting question. You don't see very often in our classes.
Right. And so that could just throw people off right away, say, I don't even know what they're talking about. So for this one here, what you'd have to do is say take 2 and press the stow key and store it in for X. And then 4, store that for Y, alpha Y. And then -3, store that for alpha Z. And so now those values are locked in there. And so I'm just going to type this expression as you see it, 4x alpha y. I could put the times sign in, but not necessary. Minus 3x alpha z squared. And before I press enter, I want to make sure you, and especially your students, know what's happening here. It's going to take the current values of the variables, substitute them in, do the calculation, and come up with the answer. It's not a magic button. It's just doing what you asked it to do. So that's letter A. So this would be a way of evaluating expressions, knowing, and then you could go back, like Jeff was saying before, if I want to say, ooh, I really wanted Z to be -4, I could go back and change that to say -4, and then go up and reevaluate that. So be aware that this isn't just a one-shot deal type thing. So there. Current slide. Okay, so we did that. So absolute value activity will probably be my last thing here. But one of the things that students think they know, but kind of don't, is the definition of absolute value. They can regurgitate it for you, but I'm not really sure they get it. So the absolute value of A minus B could be either whatever's inside there itself or its opposite. But now its opposite could be written other equivalent forms. So I could distribute that negative sign and write it like that. Or I could write that as a subtraction problem. And the ACT, you must know and be able to recognize equivalent forms. You just have to be able to do that. So
that is something we saw over and over again, and students really have trouble with seeing that those three, they get one of those answers and it's not the answer choice they expected, and so they, oh, I did it wrong. And they don't realize their answer is equivalent to one of those sometimes.
Right, and that's why with the activities we created, it gets them to think that way. In fact, this was the one that I had high school students really telling me, we never learned absolute value this way. Just stick with me here, okay? So from the student activity sheet, this is problem 4 from them on equivalent forms. And so we could rewrite this as A minus B equals 7 or equals its opposite. But a lot of times they'll write it in another way. So they have to be aware that all three mean the same thing. So again, and it's not hard, but if you take that extra minute and do that, they now have a chance. And by the way, I should point out, one of the things that Jeff and I realized is teachers don't have time to have an ACT day or an ACT week. So we wrote these things so that you can use these to integrate with what you already do. So you might want to take a couple of these and do as your examples in class, and a couple to take the place of your homework problems. But don't add to it. Just have it replace something you're already doing, because you don't have time to be able to add another day or whatever. So here's an example problem for 2016 when the test changed, which we thought was one of the hardest ones. So which of these are equal? And if you know the ideas about opposites, D comes right at you. But if you don't, I mean, some students just say, I just don't get this one. We never did anything like this before. I have no idea, or just guess.
Yeah.
Graphically, this was one of the ones that especially with color, this works so well on Nspire and on the 84, is here I have the graph of x minus 1, quantity x minus 1 times x minus 5. And what's the absolute value of that look like? And so it looks like this. And then we do several examples, and we're hoping we can see that when the graph is positive, it stays, and when it's negative, then it's flipped up. It's reflected about the x-axis. So this is both of them in red. You can kind of see the kind of purplish. See how this is flipped up. And again, remind them this is the absolute value. This was the original function, and this is both. So they can kind of see those. And this is just a huge visual for them and pretty quick for them to see. So this also, look at this problem number 54. I'm not sure Jeff mentioned this, but the problems are really 1 to 20, you should think about 30 seconds each, 20 to 40 about 60 seconds each, and 40 to 60 about 90 seconds each to get that 60-second average, because they do get harder. But for me, for this one, if you were taught properly on this one, is the absolute value of f of x equal to f of x? Yeah, it's all in the first or second quadrant. We're good. So sure. Is this one equal to? And hopefully kids will say, no, it's got to go up there and reflect above there. I'm done. But if you didn't know that and you tried to do things like composition off of a graph, are these equal? I mean, they're all true, but it would take you several seconds to figure this out. So our point is with the proper preparation, the problem is a whole lot easier.
Well, I think especially if you, the graph was, if you go back to that for a second, the f of 3 and f of 3.5, it actually crosses twice there. It's hard to see that in the picture, and so that's real confusing for students. If they get past f and g and they think it might be h, j, or k, whew, that's a monster problem there.
And not only that, if they could substitute 3.5 into those two functions, and they would be there, you know, maybe an hour and a half. So it's not going to work. So let me skip this because we are pretty much out of time. I do want to go to one quote, though, to finish up, and that is, why is it we teach so many ways to solve? Because that is a pretty common thread in what we're doing. And it takes me back to this quote by Stephen Reinhardt. I'm convinced that students can learn in more ways than I know how to teach. I haven't given up. We haven't given up. We're still looking for those extra ways. So with that, I'm going to turn this back over to Mike, and hopefully this was something that you guys could all use. So thank you, Mike.
Thanks so much, Tom and Jeff. As I get control back and Tom gives control back to me, I want to share a couple of resources that are available on our website. If you visit our website, education.ti.com, and go into the Resources tab, the first one listed is Test Preparation. So this might be something that you want to take a look at, especially after what we went through tonight. I know that the material that Tom and Jeff used tonight is proprietary for the workshops that they are running and created for those workshops. But there's still some really great things available that are for free available on our website, education.ti.com, including picking the right calculator for the exam. And there's even a section down here in the middle that says ACT resources. And I know earlier we got some questions about the SAT as well. So please feel free to visit our website to learn what's available. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents, basically my PowerPoint from tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. After the webinar, if you have any questions, feel free to give us a call at 1-800-TI-CARES or drop us an email at ti-cares@ti.com. Thanks so much, Tom and Jeff, for everything that you prepared and shared tonight. It is great to get back to school, and this is, I think, a great webinar to get that kicked off.
No, it was just fun. It went fast for me. I don't know if it went fast for you guys, but nice job, Jeff.
Yeah, we could have talked a lot more, I think.
Yeah, like 4 days? Like 4 days?
Yeah, like a 4-day workshop if we wanted.
Well, thanks so much again, Tom and Jeff, and special thanks to everyone that joined us tonight, and we hope to see you back online real soon. Have a great night.